Hi Cooper, hey, it's Mrs. Van. I just got your email question about ratios and you asked when you would use them. I thought that was a super great question. So I think this will become more clear as we do more of this practice, but look at, for example, there are a couple of real life problems where I see ratios being used regularly. One is like the mixing paint problem, right? There's almost always a mixing of paint problem. And tomorrow we're going to have one. I can't remember exactly what it says, but if they have 2 red cans of paint for every yellow can of paint in order to make orange paint, then they say, well, how, and these are like cans or pints, then they say, well, how many cans of red paint do we need if they need to use 12 pints of the yellow paint? So a ratio is basically a constant. So if for every 2 pints of red, you always have to have 3 pints of yellow in order to maintain the ratio. Or they call that proportional. If it's proportional, we need to make a proportional ratio, right? So that we would make that equivalent. So if we ended up having 12 pints of the yellow cans of paint, how many red cans would we need in order to maintain this ratio as proportional or an equivalent fraction? So we know in order to do that, one of the ways we can do that is ask ourselves, well, how did we get from 3 to 12? Well, I multiplied that by 4, and then I can multiply the top by 4 too. That's one of the easiest ways to solve a ratio problem. And so 8/12 is an equivalent ratio to 2/3, or these are also proportional measures, okay? Oops, sorry, was writing over here. Another super common real life scenario is a rate. So when we drive, and we most often the speed limit is 75 miles per hour. That is a rate. That's the constant. So if a car traveled at 75 miles per hour, we do this when we go on road trips, right? And you're trying to take a road trip, let's say from Denver to Florida. That's a really long road trip. But let's just say you're going to do that, and it's about 1,800 miles to Florida. Well, I need to also make sure that my 1,800 miles I'm maintaining my ratio, and I need to keep it in the numerator because my 75 miles per hour in this ratio, the unit is miles in the numerator, so I have to make sure that I maintain that. So if I'm going 1,800 miles, a lot of times we'll ask ourselves, well, how long does it take us to get there? Well, there's a couple of ways you could solve this. Same way as up above, I could ask myself, well, how do I get from 75 to 1,800? And then I could multiply the bottom or the denominator also by that number. But this isn't such an easy one to do. But remember, multiplication is the inverse of division. So another way of solving this problem is I could divide 1,800 by 75, and then I could figure out what the missing link is over here. So then I can figure out, well, I already did this on a calculator, so I cheated, but I know that it's 24, okay? So 1,800 divided by 75 gives me 24. So I know that 75 times 24 gives me 1,800 miles. And if I'm maintaining that ratio, I would also do the same thing to the bottom. So 1 times 24 is 24. So I know that it would take me about 24 hours to drive from Denver to Florida if I maintain this super constant rate of going 75 miles per hour and we don't stop to get gas or eat lunch or anything, right? So those are just a couple examples of real life where you would use ratios. I hope that helped.